In this lecture, we're going to learn about the std list container. Just like the std forward list container, std list is going to provide fast insertions and removals anywhere in the container. And the special thing about our std list container is that it has pointers that go in each direction. So for example, we have the ability to go forward in the list by using these pointers that go from one element to another. But we also have pointers that go in the other direction. So it is possible to move backwards in our collection. And this is going to make some things a little bit easier. For example, one direct application of this is that we can have either forward iterators and backwards iterators, and this is really cool if there is a possibility to navigate through your list in a backward fashion. And just like std forward list, the list container doesn't have a memory locality. It is possible for elements to be spread around your memory locations, and the order of the elements is going to be decided by the pointers that wire the elements together. So for example, we might have a pointer that goes from 10 to 20, just like this. And we might have another pointer that goes backwards from 20 to 10, and it might go something like this. We might have pointers like this that allow us to either go forward or backwards in our collection. And memory locality is not a requirement for std list. This way of wiring our pointers makes it super easy to insert and remove elements in the middle. So for example, if we want to add a new element between 10 and 20, let's say this is a 15, all we have to do is kill these connections and make these connections either go through 15. So we may have a pointer that goes from 10 to 15 and get another one that goes from 15 to 20. And we might have another one that goes backwards, and this way we might be able to traverse our container, and it is super easy to add and remove elements by killing connections and setting up new ones. Here are a few facts about std list. It is implemented as a double linked list, and it is doubly linked because we have forward pointers and backwards pointers. Each node has a pointer to the previous and next element. This is now obvious, and elements may be stored non-contiguously. That's why we need to go through these pointers to navigate through our list. And a poor memory locality is going to make it really hard for CPU optimizations when your list is being traversed, because we have to loop around, incrementing the pointer to move to the next element or decrementing the pointer to move backwards in our collection. std list, just like std forward list, doesn't provide random access iterators, so we don't have access to the array index operator if you use std list or std forward list. Because we have backwards pointers, it is possible to have reverse iterators with std list, so this is an improvement on std forward list, which could only move forward. And again, to get elements in our list, we have to perform a linear search to find the iterator to the element that we want to manipulate. Once we have the iterator, we can really do all kinds of crazy things. We can insert elements, we can remove elements. The same thing we did really for std list, but now we have the ability to move backwards in std list. And again, I don't recommend using std list in your code unless you have a convincing reason to do that. And the reason is that we don't have random access iterators, so it is going to be really hard and expensive to navigate through the list to find your element of interest. We have seen from the last lecture that we can use the std find algorithm, but that's really expensive. So I would always recommend using std vector as a starting point. And if you start having performance problem, then you can start looking for a better container that might give you better performance. At least that's what I do in my career as a C++ developer. To use the list container, you have to include the list header. And now that you know a little bit about the list container, you can come back to your reference documentation and read all you can about it. It is going to be a doubly linked list, as we have seen. And if we go down, we're going to see that we have almost the same methods we had for the forward list. We have a bunch of methods to do element access. You see now that we have a back element because we have the ability to move backwards. We can almost use the same iterators we had in our forward list container, but now we have reverse iterators because we can move backwards in our collection. We have a bunch of capacity methods. We have modifiers. We can clear, we can insert, we can push front, we can push back. We can really do all kinds of crazy things. You see that we have spliced versions of the methods. All these things are available to you and you can take advantage of them. And if you go down, you're going to see that we have an example of how we can use this little guy. It is going to do whatever it is you want to do in your C++ application. I am going to come back to the slides and show you a few examples pretty quick. So this is a simple example of how you can create a list. You create it like this, specifying the type that you want to store in, and you can put in data using our Brest initializer here, and you can print the data and get things printed out on the console. It is possible to use all kinds of crazy iterators. We can use forward iterators and move forward in our collection. We can use reverse iterators and move backwards. As you see down here, this is going to work pretty well. We have a bunch of methods to get the capacity, so we can print the size, the maximum size. We can check and see if our collection is empty. We can do these kinds of things. We have a bunch of modifiers we can use. For example, we can clear just like we do here. We can also insert elements at a given iterator position. Before we insert, we need to find the location where we want to do our insert. Then we can use methods like insert, which is going to insert after a given iterator. So this is how these things are going to work. We can also use the in place version to build an element in place and put that in our collection. We can erase elements just like we did for forward list. The first thing we want to do is to find the iterator where we want to remove elements. And if we have found the element, we're going to erase it just like we do here. And if we print again, we're going to see that the element has been removed. We're going to see this in a minute when we hit Visual Studio Code. We also have methods to pop data from our collection. We can pop from the front and we can pop from the back. We can print a collection here and do pop front and see that the front element is gone. If we pop back, we're going to see that the element is gone. So we can print the first collection here, pop back and see the data with our back element popped off our collection. It is also possible to push elements into the collection. We can push from the front and we can push from the back, as you see right here and right here. We can in place from the front and from the back, and we have a bunch of examples here. It is also possible to resize your std list container, and the behavior is exactly like we have seen for a forward list. So we have the ability to either resize up or down. And it is possible to swap elements just like we did for the forward list container. So if we call our swap method, the elements are going to be swapped between these two containers. And this is going to work exactly like we saw in the last lecture. We also have the ability to merge lists. So if we merge the numbers2 list into numbers1, the data is going to go from numbers2 and go into numbers1. And if we print our data, we're going to see that that's the case here. We can splice, and splicing is going to move data from one container into another completely. And here is a simple call to do the splicing. It is also possible to remove elements. We can either remove a single element, or we can use the remove if version and specify a predicate which is going to be used by the collection to decide what we want to remove. In this case, we want to remove anything that is greater than 10. So the 100 here is going to go, the 11 here is going to go, and the 12 here is going to go. And if we print the data here, we're going to see that what we removed is completely gone. It is also possible to reverse, and this works exactly in the same way as for forward list. And we can use the unique method to remove contiguous duplicates. Just like for the forward list container, if you want to move non-contiguous duplicates, the first thing you might want to do is to sort your collection and then remove duplicates, and all duplicates are going to be removed, just like we saw in the last lecture. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is list, so we're going to grab our template files just like we always do, and then we're going to put the data in place. and open this up in Visual Studio Code by dragging and dropping here. So let's do that. We will get our main CPP file. We can crack it open and remove what we don't need here. Let's get Visual Studio Code to color this nicely. And let's remove this. And we're going to include our list container. I am going to bring in our print collection function, which is going to be printing our lists as we play with them. And this is going to be using forward iterators. We have a begin iterator and an end iterator that we are using to loop through our collection. And these forward iterators are supported by the list container that we are interested in. So everything is going to fall in place and work nicely. Now, to save on time, I am going to hop over in the main function and put in all the code we're going to be playing with. And then we're going to run it and explore what happens as our program runs. If you want, you can grab the code for this lecture in the resource section of this lecture. You're going to have everything, and we can put in the code and go through it to save on some typing time. I think this is going to save us a few minutes. And this is not going to be confusing because these things are really almost similar. The difference between std list and std forward list is that for std list, we have pointers that go backwards in the collection, and this is going to allow us to have reverse iterators. Otherwise, this is completely similar to the forward list that we have seen in the last lecture. So we have code for element access, we have code for iterators, we can use forward iterators and reverse iterators as you see right here. We have methods for the capacity, we have a bunch of modifiers. So we're going to run the code and see how these things work out. I think we have nice output messages that are going to allow us to follow this. We can pass this through our compiler. We're going to use GCC. The build is good as you see down here. So let's bring up a terminal window and run our program. We can clear and run Rooster. And we can scroll all the way to the top and look at the code that we have for element access. So if we use element access here, we can print our collection. We're going to see that we print it out here. And then if we go down and get the front and back elements, we're going to see that the front element is this 11 and the back element is the 15 here. We have a bunch of iterators we can use. We can use forward iterators to print in forward order. So we're going to have the data printed out. We can use reverse iterators, and you're going to see that we're going to be printing the data in backwards order or in reverse order. We can query for the capacity of our container, which is really numbers. The max size is this huge number, so we have the capacity to store this number of items in an std list container on this system here. This is really cool. This is a huge number. If we check and see if our list is empty, we're going to get a 0, meaning that the list is not empty. If we want to get proper true and false output, we can put a HTTP bool alpha manipulator to change how the output for bool is shown here. And if we get the size, we're going to see that we have 5 elements in our collection. And this is really true. We can go down and see how to insert elements. So let's look at the code to do that. The first thing we're going to look at is our clear method. If we clear, we're going to see that the list is going to become empty. This is something you already know. We can go down and look at insert. We're going to print our collection first before we insert. Then we're going to find the iterator where we want to insert. We're going to find the 13 here. So the iterator is going to come to this place here. And then if we call our insert method, it's going to insert 333. We're going to be inserting after our iterator. This is the behavior of the insert method here. So after we insert and you see that the insertion doesn't go after insert, it is going to go in front of the insert iterator. You see that the 333 is in front of our 13 here. So this comment here is misleading. You can just ignore it. We can in place, and we are going to find the iterator where we want to in place. So let's find the 14. I think that's what we are finding here. So we're going to find an iterator to this 14, and then we're going to in place and put data in front of the 14. You're going to see that 444 is going to go in front of our 14 here. We also can erase elements, and before we erase, we need to find the iterator where we want to erase our elements. So that's what we are doing right here. We're going to find our iterator to 333. That's what we want to remove. So that's going to give an iterator that points to this location. The first thing we want to do is to make sure we have it. So if we find it, we're going to print found 333. If we don't find it, we're going to put a message out here, but we're going to find it because we have a message that we have found it here. So after we find it, we're going to erase it using the syntax here. And this is going to remove the element. You're going to see that the 333 is going to go after we erase. It is possible to pop from the front and from the back. So we can print our collection here before we pop. And if we pop the back, we're going to see that the 15 is going to go. If we pop from the front, we're going to see that the 11 is going to go. That's what we have here. We can push from the front. I think that's what we have next. So if we push from the front, we're going to see the element we push in the front appear here. We just pushed this 111 and we're going to see that right here. We can push from the back, and from the back we will push 222 and we will see that right here. So this is working nicely. If we in place in the front, we're going to see that the data is going to show up in front and from the back. So this is what we just did right here. It is also possible to resize up and down. For example, if we go in our output, we're going to see our collection. If we resize up to have 20 elements, we're going to hit this location. You're going to see that we really have many elements and the size is 20, but we can resize back down and get 3 elements as we see here. And we're going to be able to also resize back up. And if we resize back up, the elements that we lost previously are not going to come back. This is something you need to be aware of. It is also possible to swap, and our code to swap is what we have right here. So we're going to print our collections, numbers, and other numbers, and then we're going to swap the data and print the collections again. And in our output, you're going to see that numbers contains this and other numbers contains this. After we swap, numbers is going to contain this and other numbers is going to contain this. You see that they have been swapped up. Let's go down and look at some other operations. It is possible to merge collections. So let's go down and see that. We're going to see that numbers 1 and numbers 2 are going to have this data here. And if we merge numbers 2 into numbers 1, the data is going to go from numbers 2 and go into numbers 1. And we're going to see that the data from numbers 2 has been appended to numbers 1, and numbers 2 is going to become empty. So if you merge, the data is going to move from one container to another. And in this case, by default, you see that the data we get from number 2 is going to be appended to the back of numbers 1. This is the behavior you need to be aware of. It is also possible to splice, and splicing is going to move elements again from one container into another. Let's go down and look at the code here. So we're going to move elements from one collection to another. I think we should make that super clear here. It's not the range, it's the entire thing we are moving. So we're going to move numbers 2 into numbers 1. And if we do that, we're going to see that the data for numbers 2 has been appended to numbers 1. So this is the situation here. This is really something like merging, but I think we have the ability to specify a range of elements we get from the source collection. If you want to have more details on that, you can go in the documentation. I think you're going to find that it is possible to remove elements from a collection. Let's go down and look at the code to do that. Before we remove, we find the element we want to remove. So in this case, we want to remove a 1, and the first one here is going to go. And after this, it is also possible to remove using a predicate, which is going to decide which elements get removed. And for that, we use the remove if method here. So if we do that and remove anything that is greater than 10, we're going to remove the 100 here, we're going to remove the 11 here, we're going to remove the 12 here, and we're going to end up with this data here. Another thing we can do is reverse our collection. So if we have the data here, we can reverse and get the data here. This is not really hard to understand. It is possible to remove contiguous duplicates. So for example, here we have 2 duplicates for 100 and we have 2 duplicates for 11. We can remove them and you're going to see that they are going to go away. We are going to be left with one instance of those elements. But it is also possible to sort your collection. So for example, we have the data here. If we sort the data, we're going to see that everything is going to go in ascending order. And after we sort our elements and if we remove our duplicates, all the duplicates are going to go, even those that weren't contiguous in our original container. And this is something you can do. This is really all I had to share in this lecture. If you have any question, you can ask. I will do the best I can to help you out. Again, the best source of information is the official documentation for your C++ standard library. Please come back here and read documentation for all these methods if you need them. This is the best of information you're going to find in your career as a C++ developer. We are going to stop here in this lecture. In the next one, we will revisit the std vector container and explore some things you can do with it. Go ahead and finish up here and meet me there.